Okay, so this video is about the isotopes worksheet. So you should see the following picture on your page. If this is not the picture that is on your worksheet, you have the wrong video. You're going to need to go get the other video. So just looking at this for our diagram, we can see that we're dealing with potassium. We have potassium 39, we have potassium 40, we have potassium 41. And you can see because it's potassium, remember, if it's the same element, it should have the same number of protons. So we can see that here the potassium has 19 protons. None of them say that they are charged, so it should also have 19 electrons. So if you look down in this image, there's our electron cloud. Each of them have 19 electrons. And you can see for the nucleus, each of them is showing 19 protons. But the mass numbers are different, which means our neutron count is going to be different. So for potassium 39, 39 minus 19 is 20. There's our neutron count for potassium 39. Potassium 40, 40 minus 19 is 21. There's potassium 40. It has 21 neutrons. Potassium 41 minus 19 gives you 22. So there is our nucleus for potassium 41. So let's look at the questions. So the first one, what does the following symbols represent? Well, what does E negative represent? Remember, your choices are protons, neutrons, and electrons. So what does E negative represent? The electron. What does N naught? Remember, that's not a zero, it's the naught symbol. So what does N naught represent? The neutron. And then what does P positive represent? The proton. And again, I'm trying my best to write on the computer screen, and we can see it's not working out too great. But you get it, proton. Number 2, which subatomic particles are found in the atom's nucleus? So which two? If we flip back and we look at our picture, we see that in that nucleus is our protons and our neutrons. So I am going to abbreviate it. Please write the entire word out. I'm just going to abbreviate it for the fact that I'm writing this using a computer mouse. So our protons and our neutrons. Which subatomic particle identifies an atom as that of a particular element? We talked about this so much in class. It is the proton. If you have a different count of protons, you have a different element. Remember, you can change the electrons count, you get an ion. You can change the neutron count, you get an isotope. But you change those protons, you get a new element. Please explain why atoms are neutral even though they contain charged particles. Remember, we talked about this also. That is because the protons equal the electrons. The amount of positive charges equals the amount of negative charges. What do the numbers 39, 40, and 41 refer to? That is the mass number. And do we remember what the mass number, how we add that up? So that equals, that's an equal sign. That is the protons plus the neutrons. That gives us our mass number, protons plus neutrons. Write the symbolic notation for each of these, okay? So I'm going to write them out to the side over here. So the letter for potassium is actually the letter K. 39 is our mass number, so it goes at the top. And then if we look back, how many protons? 19. So 19 would go on the bottom. For potassium 40, you're going to have 40 over 19, and then a capital K. And then for potassium, 41, 41 over 19 with a capital K. Write an equation showing the relationship between an atom's atomic number and its mass number. So that is going to be mass number minus neutrons that's an equal sign, equals protons, which is equal to the atomic number. So that whole formula again, mass number minus neutrons equals protons, and protons are equal to the atomic number. For number 8, lithium has 2 isotopes, lithium-6 and lithium-7. Draw a diagram like those shown on the beginning of the transparency for the lithium isotope. Label protons, electrons, neutrons, and the electron cloud. So we are going to draw our circle to represent it, and then I'm going to draw the little thing to zoom out. This is my electron cloud. I'm drawing it for lithium-6. If we look at the periodic table, we see that lithium has 3 protons. So those are going to be my protons. I'm going to give them a positive charge. That means I've got 3 electrons. I didn't mean to overlap it. That's 3 electrons. Lithium-6, that means I'm going to have 3 neutrons in my nucleus, and I'm just going to mark those with the letter N, because if I draw them with a 0, you can't really tell. And there we have labeled it, and then there's my protons, there's my neutrons, and we already labeled the electrons. And then for lithium-7, so again, there's my circle. I know I've got 3 protons, because 3 protons tells me it's lithium. So 3 protons, and I'm going to go back and label over here 3 protons, 3 neutrons. Lithium-7 means that I've got 4 neutrons. So I'm going to put those in there, label them with an N for neutron. And I'm going to put it out here also, 4 neutrons. And then these are my electrons, and I have 3. So again, yours is probably going to look a lot neater than mine. But what you should have is a nucleus that shows for lithium-6, 3 protons, 3 neutrons, 3 electrons. For lithium-7, 3 protons, 4 neutrons, and 3 electrons. And again, please make sure you put this worksheet on the page listed in Canvas.